name is Shakir Mia and this is my video. So this video demonstrates the secure healthcare patient management system which is built for SEC 5001. The application is a Flask web app that allows medical staff to manage patient records securely. I'll walk through the system architecture, then demonstrate each security control and the machine learning detection. So this is the login page. It's the entry point to the system. And behind this page, the server uses bcrypt to hash all passwords, which are never stored as plain text. There is also a rate limiter active on this route, which I'll demonstrate shortly. So first, I'll attempt a SQL injection attack. So I'll type the classic payload single quote or one equals on into the username field and submit it. So you press login now. If the login fails, this is because all database queries use parameterized statements, which then the input is treated as data and never as a SQL. The injection attempt is completely neutralized, which can also see in the terminal that it was logged as a failed attempt. So we log in as a doctor. So now I'll log in with a legitimate account, doctor underscore Smith, password doctor at 1234. So as you can see, the login is successful. This is the patient's dashboard. As you can see, the doctor can see all patient records. Notice the role is shown as a doctor in the top right. So every page load validates the JWT token stored in the session, or if it's missing or expired. So the user is redirected to log in automatically. So the test 2, you can see now the test role based access control. Whilst it's logged in as a doctor, it will manually type the admin's URL into the browser. So the server returns a 403 forbidden error immediately. So this requires a check from the JWT payload on every request. And a doctor cannot access admin pages, so no matter how they can try to reach them. So as you can see, the test 3, I'll be testing on the cross-site scripting. So I'll open a patient record and edit the notes field. So click on the patient, edit notes, paste. I'll save this and then view the record. So the script tag is displayed as plain text and it does not execute. This is because the sanitize notes function first strips the HTML tags, which is then escapes any remaining special characters using markup safe. So the output is harmless. So this is the audit log. So I'll log out and log back in as admin. So this is the admin log. Every action in the system is recorded here. Logins, record views, edit actions, failed attempts, and all with username, timestamps, and IP addresses. And this log is only accessible to admin accounts and feeds, which are directly into the ML anomaly detection module. So test 4, which will be the brute force rate limiter. I'm going to test the brute force protection. So I'll log out and attempt to log in with the wrong password multiple times in a quick succession. So let me log out now and attempt 6 rapid logins. So after 5 failed attempts, the sixth one is blocked with a 429 too many request error, which is a limiter tracking login, which is request by IP address. So this is like a secondary control, consecutive failure. So within like 15 minutes login, it locks the account entirely. So everything's recorded in the audit log. So the test 5 for anomaly detection. So finally, I'll demonstrate the machine learning anomaly detection, which I'll navigate to the ML test endpoint. So this page runs the isolation forest module against several test scenarios. As you can see, the results here, access patterns are classified as normal, but it stimulates suspicious activity. So, like 150 patient records accessed at 3 a.m. with no edit actions is most likely going to be flagged as a anomaly with the threat type after hours exfiltration. So the model uses five features: record accessed, edit action, failed logins, hour of a day, and total actions. So this was trained on 42 baseline samples representing normal clinical staff behavior, which is across two shifts. When an anomaly is detected in the live app, an alert banner is shown to the admin and the event is logged. So now time to wrap up. To summarize, this section implements security at every level and layer. So Bcrypt password, hashing, and JWT session management protects authentication. And this is like a role-based access control, which restricts data by using role. So parameterized queries prevents SQL injection, input validation, and sanitization prevents XSS. So this rate limiting and the account lockout prevents brute force, which then is a audit login monitors, which monitors all the activities. And the isolation forest ML model provides adaptive anomaly detection. So all of these controls were built in from the requirement phase and not added afterwards. So as you can see, this is my video. Hope you enjoyed and thank you for listening.